A book of mass m lies on the top of a table of mass capital M that rolls freely along the ground. The coefficient of friction between the book and the table is mu. A person is pushing the rolling table. What is the maximum acceleration of the table so that the book doesn't slide backwards relative to the table? Let's consider quickly what you should know about friction, static and dynamic. For example, there is a box on the floor, and if you apply a thrust force of 100 newtons and it doesn't slide, it doesn't move, what does it mean? It means that your force is just balanced by the frictional force. You apply 200 newtons and it also doesn't move. What does it mean? 200 newtons, this force is also balanced by the frictional force, and at some value of the thrust or driving force, it just begins to move. And for example, let it be 500 newtons. And also the frictional force is equal to 500 newtons, but it's a moment when it just starts to move. And when we consider the frictional force at this moment of time, and the general formula for the frictional force is mu n, where n is a normal reaction. And definitely always there are two additional forces, it's mg and normal reaction, but they don't influence on the horizontal motion. Why? Because if you consider the second Newton's law and then in components or in projection on x-axis or on horizontal, these two forces are perpendicular and their components are equal to 0. And in general, the frictional force is equal to mu n. And when we consider this moment of time, it's called this coefficient of friction is called static coefficient of friction because it doesn't move, so it's called static. And what is then? It's quite easy. If we consider vertical axis, you can see that n is just balanced by mg, so n is mg. But it's only for this situation. For another problem, you should consider the second Newton's law in components on x-axis, on y-axis, and just consider some equation and solve for n. But here it's quite simple. N is just mg, and hence the frictional force is equal to this. And for this example, it's 500 newtons. And notice that coefficient of static friction is calculated at the moment when it just starts to move. And there is a formula which is given in data booklet that frictional force is less or equal than mu static and multiplied by normal reaction. And now you understand why there is less or equal, because it says that the frictional force static is less or equal than 500 newtons. It may be 100, 200 and up to 500 for this example. And don't get confused, mu s is the only one value, it has only one value. For example, when there is 200 Newton force, it doesn't mean that you should consider 200 is mu s mg and you calculate mu s, which is less than this value. It doesn't make sense, it's not correct. The static frictional force is less than this critical value. And when it starts to move, this situation is called dynamic, it means it is moving. And again, the frictional force is also mu n, but now this coefficient is called dynamic. And when it starts to move, and when it is moving, the frictional force decreases a bit. And And now it, for example, not 500 but 450, and to keep it moving at constant speed, you just should balance this force, and you should apply a thrust force of, for example, 550 newtons. And as equation of a motion, it looks like a thrust force to driving force minus the frictional force is equal to ma, and it's mu dynamic mg, and for example it's 450, and when you provide 450, you can see ma is 0, and if you provide the greater driving force, for example 600, you can see that the resultant force is 150 and is equal to ma. And hence a graph, the frictional force against applied force looks like this at 45 degrees. Why? Because they are equal. It's called static friction. Up to some moment of time, it's threshold of motion, and then dynamic friction, and hence there are the next formulas in data booklet that frictional force is less or equal than mu static R, or M, it's normal reaction. It's for static, and for dynamic it's just equal mu dynamic M. And let's consider an object on the inclined plane, and this situation looks like this. Let's consider forces mg, weight of the gravitational force, normal reaction perpendicular to the plane. It tends to move downwards, so the frictional force opposes motion and it doesn't slide. So frictional force opposes, or actually it doesn't move because frictional is in this direction, and let it be an angle theta here. And second Newton's law, the vector sum of all forces mg plus n plus frictional, here it's static because it doesn't move, is equal to ma. And let's consider in components. Let x-axis be in this direction, y-axis be in this direction. So in component or in projection on x-axis, component of mg it's plus, and it's this vector, and theta is here just from geometry, and you can see this magnitude of this vector, it's mg, and its opposite side, so it's sine, so it's mg sine theta, and component of n is 0 because it's perpendicular, and minus frictional force, and is equal to 0. And you can see that component of mg parallel the slope is just balanced by the frictional force. And in components on y-axis, n minus mg cosine theta is equal to 0. And for any situation, frictional is mu m. And hence, we can see that mg sine theta is equal to f frictional, so, and it's static situation, so mu static, and n is mg cosine theta, and divide both sides by cosine, we get that tangent theta is equal to mu static. And notice that we consider a moment when it just starts to move, and hence from this equation we can get some critical value of theta, which is arctangent of coefficient of static friction, or you can calculate critical angle of theta for given coefficient of static friction. And if a given angle, or if you increase angle theta, and when theta is less than this critical angle, it doesn't slide, and when theta is greater than this critical value, it will move downwards. Or you may calculate for given angle, you may calculate coefficient of static friction required so that it doesn't slide. And hence, if actual coefficient of static friction is greater, it means that frictional force is greater than required critical value, so it will not move in. If actual is less than this critical value, it means that it's not enough for given frictional force to keep it not moving down, so it will slide. And now let's consider given problem, and let's consider this object, small object, on a book on the table, and let's consider forces which act on this object. Definitely there are mg and n, but we will consider in horizontal direction, so we don't need n and mg because they don't influence on the horizontal motion. And what about friction? Definitely it's static friction, but what is the direction of the frictional force? It tends to move to the left relative to the table, or just imagine that it's a frictionless surface. So if table is moving to the right, this object will move to the left, and what frictional force is always in opposite direction to the direction of motion, so frictional force is to the right. It's static. And notice that this force is applied to the table, not to the book. And when we consider the second Newton's law, we consider all forces applied to a given object, not to another object. So if we consider a book, forces must be applied on given book. And they both are moving with acceleration, same acceleration. So the second Newton's law for the book looks like this. If there is only one force, frictional is equal to ma. And frictional is what? Is less or equal to mu static. Here it's just mu n is mg, because in vertical direction there are two forces n and mg which are balanced, and friction is ma, so it's ma less equal to mu mg, and its condition for what? It doesn't slide. And you can see m cancels, and m acceleration is less equal than mu g, and hence a maximum possible value of a is just mu g, so it's b. And actually that's all for this question, but let's find the greatest possible value of this force F applied by the person, so that the book doesn't slide. So now let's consider a table, and also we'll consider only horizontal forces or second Newton's law in components on the horizontal axis. So what forces act on the table? This applied force F, thrust force F, and the same force F friction is equally the same. Why? Because it's action reaction pair, and the forces arise in pair, action and reaction. So it's action reaction, but this force, it's friction or table on the book, and when you consider a book, it is applied on the book, and this force is what? Book on the table. And if you consider table, it will be to the left, and they are of the same magnitude, and there are no other horizontal forces. Vertical forces don't matter because their components are zeros, and acceleration to the right. So second Newton's law in projection on x-axis, it becomes F minus frictional is capital MA, because we consider an object of mass m, and hence F is F frictional plus MA. But a book doesn't slide. If a book doesn't slide, this frictional again must be this. So if F is and 1 this is less than, so friction should be less or equal than mu mg, and actually it's MA is the same, so we can write it's mu mg or just MA plus MA, or M plus MA, and A max is this, so it can be calculated. Hence we get the maximum possible value of this force, so that it doesn't slide, and hence if force is greater than this critical value, a book will slide. So or F is less or equal than M plus M mu G. And that's all for this problem.